July 23, 1983, 41,000 feet above Ontario, Canada. A brand new Boeing 767, the most advanced airliner Air Canada has ever owned, is cruising toward Edmonton with 69 people on board. Just after 8 p.m., a warning sounds in the cockpit, then another. Within minutes, both engines go silent. No fire, no storm, no mechanical failure. The aircraft has simply run out of fuel at 41,000 feet, with half the flight still ahead of it. This is the story of how a single arithmetic error turned a 100-ton airliner into the world's largest glider, and how two pilots landed it without engines, without most of their instruments, on a runway that was no longer a runway. In 1983, the Boeing 767 was the future. Glass cockpit, two-man crew, computers replacing flight engineers. Air Canada had just taken delivery of 4 of them, and these aircraft were new in one more way, one that had nothing to do with technology. Canada was in the middle of converting to the metric system. Air Canada's entire fleet, every DC-8, every 727, measured fuel in pounds. The new 767s were the airline's very first aircraft to measure fuel in kilograms. Keep that in mind. It's about to matter more than anyone imagined. Flight 143 was scheduled from Montreal to Edmonton, with a stop in Ottawa. But the aircraft had a known problem. Its fuel quantity indicating system was acting up. In the cockpit, the fuel gauges were blank. Those silent engines at 41,000 feet? Their story begins here, on the ground, at a gauge showing nothing at all. Now, a blank fuel gauge doesn't automatically ground an airliner. Procedures existed for flying with the gauges inoperative. The fuel load had to be measured manually, using dripsticks under the wings and cross-checked by calculation. The dripsticks give you a reading in liters. But the flight plan needs a weight because fuel burn is calculated by mass, not volume. So the ground crew and flight crew had to convert liters into kilograms. And this, right here, is the point of failure. The dripsticks showed 7,682 liters already in the tanks. The flight to Edmonton required about 22,300 kilograms of fuel. To convert liters of jet fuel to kilograms, you multiply by its density, roughly 0.8. 7,682 liters works out to about 6,200 kilograms on board. But the number the crew used wasn't 0.8, it was 1.77. 1.77 is a real number. It's the density of jet fuel in pounds per liter, the figure every Air Canada crew had used their entire careers on every other aircraft in the fleet. Do the math with 1.77 and 7,682 liters becomes 13,600, and everyone read that number as kilograms. The paperwork said they had 13.5 tons of fuel. In reality, they had 6. They calculated the top-up the same way and pumped in less than half of what the airplane actually needed. The computers were fed a fuel figure of 22,300 kilograms. The aircraft actually carried about 10,000. Flight 143 left the ground with less than half its required fuel and no working fuel gauges to reveal it. Multiple people checked this arithmetic. Ground crew, both pilots. The error survived every check because everyone was fluent in pounds, and the kilogram was 4 weeks old. For the first hour, Flight 143 was perfectly ordinary. Dinner service, cruise at 41,000 feet. Captain Bob Pearson, 26 years with the airline. First Officer Maurice Quintal working the radios. Just after 8 p.m. over Red Lake, Ontario. Low fuel pressure in the left fuel pump. Pearson assumed a failed pump. Reasonable, The computer said they had plenty of fuel. But he took no chances. At that first warning, he turned toward Winnipeg and started down. Then a second warning. Then, minutes later, the left engine flamed out. They still believed they had fuel. Then the right engine stopped. Here's what most people don't know about a modern glass cockpit. The screens run on engine-generated power. When both engines quit, most of Pearson's instruments simply went out. What was left? A magnetic compass, an artificial horizon, an airspeed indicator, and an altimeter. A Boeing 767 without engines wasn't in any manual. No procedures, no checklist. No one had planned for the world's most advanced airliner to become a glider. But by pure chance, the man in the left seat was a glider pilot. Pearson slowed to 220 knots, his best guess for the optimal glide speed. Below the floor, a small emergency turbine dropped into the airstream, a ram air turbine, spinning just enough hydraulic pressure to move the flight controls. Quintal began calculating. They were losing 5,000 feet of altitude for every 10 miles flown. He ran the numbers against the distance to Winnipeg. The math wasn't close. They would hit the ground miles short of the runway. Quintal searched for anything closer and found it. Gimli, a retired Air Force base he had once served at, close enough to reach. What Quintal didn't know, part of Gimli had been decommissioned and converted into a motorsport park. And on this particular Saturday evening, it was race day. The old runway was lined with cars, campers, and families. Pearson turned toward Gimli. One attempt. No engines meant no go-around. Whatever happened at that runway, the aircraft was landing. Behind the cockpit door, the cabin crew briefed 61 passengers for something no safety card covered. The inquiry later recorded that some of the flight attendants didn't know an aircraft this size could glide at all. As far as they understood it, they were going down. Without hydraulic pumps, there were no flaps, no slats, no speed brakes. The nose gear, dropped by gravity alone, refused to lock. And as Gimli came into view, Pearson saw the next problem. They were too high, far too high, and far too fast. An airliner has no way to fix that. A glider does. Pearson did something no airline passenger is ever supposed to experience. He crossed the controls and threw the 767 into a forward slip, flying sideways to the airflow, trading lift for drag, dropping like a stone, with the runway still lined up. Glider pilots do it every weekend. Nobody had ever done it in a wide-body jet. On the ground, race crews heard almost nothing. 100-ton aircraft approaching in near seconds. The 767 touched down hard and fast, far above normal landing speed. Pearson stood on the brakes. Tires blew out. The unlocked nose gear collapsed, and that failure, of all things, helped. The nose, scraping along the tarmac, dragged the aircraft to a stop, short of the spectators. 17 minutes after the second engine died, the Gimli Glider was on the ground. 61 passengers, 8 crew, a drag strip full of families. Everyone lived. The evacuation's worst injuries came from the rear slides, angled too steeply because the nose was on the ground. The investigation found no villain. That's what makes this story matter. The Board of Inquiry put it in writing. Calling this a metric mix-up would be, their words, simplistic and inaccurate. The question was never that the fuel ran short. The question was how the shortage could have happened at all. The fuel quantity system had failed in a way maintenance didn't fully understand. The minimum equipment procedures were ambiguous, and the crew believed dripstick measurement made the flight legal. The conversion error wasn't one person's mistake. It passed through multiple hands because An entire airline's mental arithmetic was calibrated in pounds, and this one aircraft spoke kilograms. The system had no guardrail for the transition it was living through. One number, carried across a unit boundary, defeated every safety check in its path. Captain Pearson was initially demoted. Quintal was suspended. 2 years later, the same airline's pilots received the Fédération Aéronautique Internationale's first ever diploma for outstanding airmanship for the same flight. The aircraft itself was repaired and flew for another 25 years. Pilots called it the Gimli Glider until the day it retired. Aviation changed quietly after Gimli. Fuel procedures were rewritten, cross-checks standardized, and unit error became a phrase every engineer learns. It didn't stick. 16 years later, NASA lost a $327 million Mars spacecraft to a conversion between pounds and newtons. That story is coming on this channel. Every disaster has a point of failure. Find it, and you understand the whole machine. This has been Point of Failure. Thank you for watching.